All right, so last thing we didn't finish up from law of sines yesterday was the third case, which is when you have side-side angle. Okay. Out of every case that we study, even the ones we haven't done yet for law of cosines, this is the one that you have to be a little careful with. Okay. 3 different things can happen. It can end up being a normal problem where you solve it, and there's one solution, just like the problems that we did yesterday. It can also end up where there's 2 solutions. Okay. Think about 2 solutions as it's not really harder, it's longer. You don't have to do anything different. You just have to do the same thing twice. Right? Like it's not like there's new calculations to learn. It's the same stuff twice. And then the third case is when there's no solution. All right? So we're only doing the first half of the section. So we're just going to focus on the one solution case today. And then when we come back next time, we'll probably have like a warm-up question where we practice a 1 solution, and then that'll lead into me going over the 2 solution and no solution. All right. So this topic is going to kind of come back again next academic week. But I think it's a pretty straightforward topic, so it's not that hard to kind of remember it. Much easier than the section before. All right. So here's the same information that we had up above. I just put it in the table form. Okay. Let's draw the picture just to see if we can figure out what type of triangle it is. Okay, we already know it's going to be the third type, but let's just see when we draw it. So we've got A, and what's the name of the angle that we put across from A? Alpha. And then we've got B, and the Greek letter across from B, beta. And then we've got C, which we don't know, and gamma. So if we look at what we've got a side, and an angle. Is the angle between the 2 sides that we know? No. Gamma is between the 2 sides that we know. And if I had given you gamma, you wouldn't be able to do it. You can't do SAS, not with what we've learned yesterday. Okay? But the angle is not between the 2 sides, so it's SSA. Okay. So, when you have SSA, if you set up your table like I've been showing you, you can tell that it's SSA just by looking at the table. I have a row that's complete. First of all, that tells me that it's law of sines. Anytime you have a full row. I also have a row that's completely empty, and I have no way to find anything in this row. Right? It's impossible. I can't get C, and I can't get gamma. That tells me that it's a side-side angle. Okay? Totally empty row. All right. So because the last row is empty, you can't use it at all. So for now, ignore the C and ignore the gamma. So what do you think you have to find first here, because you at least have some information in this row? Yep. Beta. You have to get beta first. Sometimes you have a choice what order you solve it in. This one you don't. Beta is first. Okay, so let's find beta. Okay, Alec, which row has everything in it?
The top row.
The top row. And can you tell me how I would write the top row in my proportion?
It would be the sine of 40 degrees over 3.
Yep. Sine 40 over 3. And now on the other side, sine beta over 2. Now, before we even go any further, that already looks a little different than what we did yesterday. What's different? Beta doesn't have a number. The angle doesn't have a number. Yesterday, it was always the side that didn't have a number. It's not the side. It's the angle. Right? But we still try to solve it the same way. So you're going to cross multiply. 3 sine beta equals 2 sine 40. Okay, and now we have to get sine beta by itself. And we did, in fact, we did ones a lot more complicated than this in the last section. So how do you get sine beta by itself? You would subtract 3 if you had this.
Divide by 3.
You divide by 3. Yep, but divide by 3. Divide by 3. Don't worry what the other side comes out to. Just leave it just like that. Okay. Now, we have to get beta by itself. So what do I have to do my last step? Yeah. Yeah, we're going to take the inverse sine of everything that's on the left and just kind of squeeze it in here. We're going to take the inverse sine of everything that's on the right. Inverse sine and regular sine cancel out. And there is your answer for beta. Okay, let's type it in and see what we get. Okay, switch to degrees because that's, you can do these in radians or degrees. We're doing them in degrees. So inverse sine, 2 sine 40. And what do I have to do before I hit divide by 3? Right, I gotta close that, divide by 3, and then finish it off. So this, assuming I typed everything in right, and I did everything right up to this step, this is not a no solution problem. How do I know? I just got a solution. Right? So that means there's at least one solution, and I also have to check if there's a second one. So 25.374. Okay. What I usually do is I write it in the box, but I just put it up higher. And if there's a second one, I'll put it below. And if there's not, then it's fine. Okay, that angle is between 0 and 90. So what kind of angle is that? Yeah? It's a reference angle. So we're looking for another quadrant to get an answer in. 25.374 is right here. Now, there's only one other quadrant that the answer could even possibly be in. What shape are we dealing with in this problem? A triangle. How big can an angle be in a triangle? It can't be any bigger than what? Can't be bigger than 180. I mean, it could be like 179.9, right? Because if it's not a right triangle, and then it might look something like this. You know, it could be a really, really big angle, and the other two are very, very small. But it can't be bigger than 180. So looking at that diagram, what are the only two quadrants there that have answers that are less than 180? Yeah? Yeah, quadrants 1 and quadrants 2, A and S. It's impossible to have an answer there. Those are between 180 and 270. It's too big for a triangle. Can't be there. That's between 270 and 360. Way too big for a triangle. So the only other place you can have an answer in any of these kinds of problems is quadrant 2. How do you get an answer in the second quadrant now that we have the reference angle? Yep.
180 minus 0.
Okay, so 180 minus the reference angle. Now, if this was an algebra problem, we'd just write that down. That's the answer. But this is a problem about a triangle. So in a triangle, all the angles have to add up to be what? They all have to add up to be 180. So 154.626. Is it? Well, we'll start with this. What angle did they give me to start with? Alpha. And how much is alpha?
40.
It's 40. If there's a second answer, we just found it. It's 154.626. Could that angle fit in the triangle with the one that was given?
No.
No, why not?
60 is 180.
It's too big. If you add what we think the second answer would be, plus what they gave you, that's 194. That's too big. So in this case, the second answer doesn't work, and we can forget about it. Now, let's say they have given you an angle of 10 to start with. Well, if they gave me an angle of 10, and the second one came out to 154, can you fit 154 and 10 in the same triangle? Yeah, then it would have fit. Okay, but we're just focusing on the one solution case, so the second answer is not going to work for now. Okay. So when you're finding the three things that are in the boxes, it's pretty much all or nothing. They either all have one solution, they all have two solutions, or they all have no solution. Whatever happens in one box, that's what's going to happen in all of them. You don't have to worry about the three things that they gave you. Those are done. You never have to find anything for A, B, or alpha. Just the things you don't know. Bless you.
Thank you.
In this problem, everything is going to have one solution because beta only had one solution. Any questions on why? Any questions on how I got the second answer? Bless you.
Thank you.
Any questions on how we figured out the second answer doesn't work? How we determine that? I think I have it. Actually, I think I have it written out here. So if you already know this, you don't have to write it. But to check if there's a second answer, it's 180 minus your reference angle. Okay, we've been making that chart all week, so you probably know that. So you do 180 minus the reference angle, and then you see if it's possible for that angle and the one that was given to fit in the same triangle. So for us, 180 minus the reference angle gave us the 154, but we were given 40 to start. If you add together what you were given and what the second answer would be, it's greater than 180. It's too big. So the other answer is too big. So you can forget it. Okay. So now that we've got beta and we know the second answer doesn't work, what's the second thing I could now find here? Yep.
C.
I can't get C because that row's empty.
Yeah,
But I can get gamma. Yeah, that's the second thing. How do I get gamma now that I know alpha and beta? Yeah.
Add alpha and beta and subtract it from 180.
Yeah, from here it's just going to be like a normal problem. Right? Just finish it like we did yesterday. So 65.374 and subtract that from 180. So gamma is 114.626. Now we've got a piece of information in the last row, which means I can now finish this up and find C. That's always the order you have to go. Okay. Find the angle that you're missing, that you know the side for. Then once you have that, you add them up and subtract from 180. There's your third angle. And then use that angle to get your third side. So this problem really builds, which means if you mess up beta, well, what does that mean if you get beta wrong? It's all wrong. Yeah. So you just have to go through it carefully. Okay. So now let's find C. Okay. I've got a choice of two rows that are full. Row A and row B. I would pick one row over the other to use. Yep. The first row, right? Everything's given, nice numbers, no decimals. So just like we did here, sine 40 over 3 equals. And Connor, what is going to go on the other side to find C?
I'd be sine of the gamma
Over
or C.
C. So sine 114.626 over C. All right. So Connor set up our proportion. Last thing you always do to solve a proportion is cross multiply. So you're going to have 3 times the sine of 114.626. divided by sine 40. Now, I know we're using something that's rounded, which generally is not a good idea, but I mean, it's rounded to 3 decimal places, so you should be fine. All right, so 3 sine 114, 626. Make sure you close the parenthesis. A lot of people that come up to me during the test, they're like, I'm not getting the right answers, nothing seems to be working, and it's just because they're typing something in wrong. Divided by sine 40. Okay. So we get 4.243. Okay, so I'm just going to check. Biggest side is with the biggest angle. Smallest side is with the smallest angle. And any 2 sides added together should always be bigger than the third. That's a rule in a triangle. Okay. So if you add A and B, you get 5, and that is bigger than C. If you add B and C, you get 6.2, and that's bigger than A. Right? So any 2 sides added together have to be bigger than the third. Okay. And that's how you solve side-side angle. So this question on the test would actually have 4 parts. This would be 1, 2, 3 of the parts. And the 4th question would be, how many answers did you get? Like, how many different triangles can you create? And the answer here was just 1. The second triangle didn't work. The second set of angles and sides, they didn't work. So there's 1 question like this on the test. There's one like that. And 1 like that. So there's three of these kinds of problems, and they're worth 10 questions on the test. And the test has a total of 19. So more than half the test is just on the stuff we learned yesterday, because I thought this stuff was easier than the stuff from the other 2 days. So any questions on the law of sines? Okay. All right, so that was the homework we did. We'll go over any questions on the homework, and then you'll have the rest of the time to review.